So now we are moving on to the last category of operators, which are known as a special operator. Special operators. Are you all listening? Special operators. So under special operators, those operators which cannot be categorized in any of the above mentioned categories, we are just grouping it together. The comma operator, size of operator, address and the pointer operator, member selection operators. These are the operators which cannot be categorized under or cannot be grouped under any of the above mentioned operators. So if you refer internet, you will be getting some other operators also included in, and some may be missing, but it's not like correct rule to have all these, special operators means those which cannot be categorized under any of the above mentioned categories of operators. So the comma operator, size of operator, address and the pointer operator, and the member selection operator are those operators which are coming under special operators. So the comma operator and size of operator we will learn now. Later on, when we learn about pointers in the chapter pointers, we will be learning about the address and the pointer operator. The member selection operators will be learning more in depth when we are having the structures and union. That chapter, when we are learning, we will be learning more about the member selection operator. Some of you have studied C++, will be familiar of this member selection operator. So we will be seeing only the comma operator and the size of operator. So here the comma operators are used to link the related expressions together. When we are usually using a variable, we will be following that. First, we will be assigning a value to a variable, and then we will be using an expression and with the variables and evaluating the expression. So if you want all the three or four related assignment and evaluation of an expression to be written as in a single line. If you want to write it as a single line, you can use the comma operator. So related expressions, if you want to have it in a single line, you can use the comma operator. So the comma operator separated assignments will be within the parenthesis. So you will be putting within the parenthesis, and we will learn about how the order of priority will be changing using parenthesis. That I will explain in the next slide. But now, for the time being, the comma operator is used to link related expressions together. So here is an example down which I have given. Value equal to, in bracket we are giving x equal to 10, y equal to 5, and x equal comma x plus y. So in this three related expressions, that is x equal to 10, y equal to 5, and x plus y are the three related expressions which are linked by the comma operator. So this means that here, that x is assigned a value 10, y is assigned the value 5, and we are evaluating the expression x plus y. And after evaluating the expression, the value of x plus y added is assigned to the variable called value. So there are three things which are happening in this, and all these are related because x plus y can be evaluated only if the value of x is assigned 10 and value of y is assigned 5. So usually if you are writing this now, you can have it as in three separate lines. In the first line, we will be giving x equal to 10. So, and then we will be putting a semicolon, right? We are just assigning the value 10. And for the y, if you are assigning the value 5, we will be assigning the value 5, and then you put a semicolon to end the line, and in the next line we will be using, suppose value is a variable which we have declared in order to store the value of the expression x plus y. In value we will be writing, nice handwriting, no, x plus y. So this will be evaluated now, and the value of x plus y will be assigned to the variable called value. Yes, ma'am, Deepak is telling. Okay, so here how x plus y will be evaluated and it will be assigned to the value variable called value. Usually we will write it in three separate statements, right? And you know that this line can be evaluated only if X is assigned the value 10, Y is assigned the value 5. And these three are related. So if you want to have all the three in a single line, so all these will be linked together by using a comma, and you can have you can link all the three expressions which are related using a comma operator. So this has an order of evaluation. It will be evaluated from left to right. So that means you cannot evaluate the expressions which are linked using the using comma operated from right to left. Right means this side, right? So you have to evaluate from left to right. So this means the first x value should be assigned the value 10, y value should be assigned the value 5, and then we are evaluating x plus 5. So a comma linked list of expression is evaluated left to right, and the value of the rightmost expression is the value of the combined expression. So after evaluating or assigning these two, then the combined value x plus y, the value will be assigned to the variable called value. So this will be the combined, the value of the combined expression. So the comma operator has the lowest precedence of all the operator. You know, comma operator in the table of or the order of precedence, it will be listed as the operator having the least precedence or the lowest precedence. So how this will be? So in order to evaluate an expression which is separated by comma, you have to put within the parenthesis. You know the difference between parenthesis. No, parenthesis is an operator which is having the highest precedence. Comma is an operator which is having the lowest precedence. So in order to evaluate an expression which is separated by comma, you have to, that is comma which is having the lowest precedence, you have to put the whole expression or the related expressions within parenthesis. Got it? The first assign the value 10 to x, then assign the value 5 to y, and finally assign the value 15 to the value or the variable called value. So without this bracket, it will not be working as we were telling in the above line. So within you know, comma is having the lowest precedence while bracket is having the highest precedence. So in order to evaluate an expression in the order from left to right, you have to use all the related expressions separated by comma within parenthesis. Is it clear? So this much you have to write for the special operator, which is the comma operator. The next special operator is the size of operator. Size of operator is a compile time operator. Oh, clear, ma'am. Deepak is today attending, I think. So all should be sending notes. I'll be, yesterday I had given no. Like that I'll be giving attendance only with your notes. The size of operator. Size of operator is a compile time operator. It's a compile time operator. During compilation only, it will be working, and when used with an operand, it returns the number of bytes. So the only peculiarity is during execution, it is depending upon the compiler also, right? So it will be returning the number of bytes used. It's not the number of bits. It will return the number of bytes the operand occupies. Number of bytes the operand. So again, size of operator is a unary operator. Unary operator which takes only one operand. The operand can be either a variable or it can be a constant, or you can have a data type name. Data type name. So these are the three possible operands for a size of operator. It is a unary operator, and it can be the for the size of operator, you can have a variable name. Sum is a variable name, okay, or you can pass a constant also. If you are passing 10, it is taken as an integer and it will be returning. For integer, it will take 2 bytes, right? And if you want, you can pass a data type also. Long int is a data type, so it will be returning 4 bytes. So depending upon the operand, number of bytes used by the operand. So if it is a variable which is declared as an integer, it will be returning 2 bytes. As it is an operator which is working on the compile time, it is also dependent upon the compiler as well as the system configuration. That means if the system, yesterday I was telling about 64-bit and 12-bit, 16-bit and not 12-bit, 16-bit, 8-bit and all, no. So it is also dependent upon the the bit, the configuration of your system. Again, it is dependent upon the compiler also. C compilers are also, I have shown you one online compiler, right? So it depends upon the compiler which we are using, as well as the system configuration. So, but still, size of operator will be returning number of bytes allocated for a constant or a variable or a data type. When we declare a variable as a special as a data type, int, how many bytes will be allocated? So here is an example for running and seeing or using the size of operator. Size of followed by in bracket, you can either give the data type. So here in this example, I have used only the data types: character, short int, also you can give short int, and then integer, float, double. So here when you are running the program, you will be getting as an output the number of bytes used by or allocated when we are declaring a variable as character. So it will be returning 1 byte. Character will be allocated 1 byte, right? Short int also, short or short int you can use, it will be returning 1 byte. But while running, I'll show there is some difference, but still. And then when you are declaring a variable as integer, it will be allocated 2 bytes. So when you are running this program, it will be returning 2 bytes. And then float, so it will be returning 4 bytes, like that. So we will run and see what will be the output. So again, as I told, it will be depending upon on the compiler and the system. So for the time being, you can just see here the short int will be returning 2 bytes. Actually, it will be returned. It is allocated 1 byte. Okay. So you can run and see here, as I told, here short, it is given 2 bytes. Actually, it is only 1 byte. Character and short int will be 1 byte only, but the later, depending upon the compiler and the system, allocation, it may differ. So here, this this is an example for the size of operator. So you can execute in your system for all the data types. Listen here. I should see later on all the data types what you have studied, and you can run the program and send me the output. So that is over. So the size of operator is also over. Now we will see the next topic: precedence and associativity of the operators. So till now we were studying only the categories of operators. Now we are going to see how in each category I was mentioning about the precedence order. Among the arithmetic operators also we have 3 levels of precedence. One is the unary addition and subtraction. The second high priority will be for the multiplication, division and modulus. And the third, or the least priority among the arithmetic operators, will be for the addition and subtraction. So here now we will learn about what is precedence and how associativity of the operators will be taken into consideration for those operators which are having the same precedence. So the computer evaluates an expression considering 2 things. One is the precedence order, the other one will be the associativity of the operators. There are 2 things which will be considered by a compiler and a system, that is precedence and associativity of the operators. The sequence in which the operators in an expression are processed or evaluated. The sequence or the order, this term you can rewrite with the order also. The sequence or the order in which the operators in an expression is evaluated. Processed means it is evaluated, is known as the precedence of operators. Now, this is known as a precedence of operator. Now, the order in which the operators having equal precedence, this term should be there when you are writing the definition. Operators having equal precedence are processed or evaluated is known as the associativity of the operators. So there can be 2 types. So here, what is the difference between precedence and associativity? Precedence is merely the order in which the operators are evaluated in an expression, while the associativity of the operators will be taken into consideration if 2 or 3 operators which are present in the expression is having the same precedence. So tell me 3 operators which are having the same precedence in arithmetic operators among the arithmetic operations. Message in the chat box. What are those or what are the operators which are having the same precedence in arithmetic among the arithmetic operators? Message in the chat box. Let me see who are listening. Operators having same precedence in arithmetic. Agash B. Only one. Praveen, what happened? He has raised his message in the chat box. What are the 3 operators which are having the same precedence in among the arithmetic operators? All are dreaming and sitting. I can't see any answer in the chat box. Only 3 students have replied. Never expected. Now, in between, I'll be asking a question. Rahul Pradeep, which 3 operators are having high precedence and having the equal precedence among the arithmetic operators? So this way, you have given 2 operators having the same precedence. In that way, it is correct. But I was asking the 3 operators which are having equal precedence. Okay, Nirma B, she has given the 2 operators which are having the same precedence and the other 3 operators which are having the same precedence. Others don't know, right? Others don't know what is arithmetic operators and which are having equal precedence. Which 3 operators are having equal precedence among the arithmetic operators? Huh? The first operator, category of operator what we studied. Which 3 are having equal precedence? Multiplication, division and modulus. Where is Deepak? I know he will be just giving a message and then leaving. Where is Deepak? Deepakas. When I am calling, you should be there. Don't think that in between if you are... tell me what are the 3 operators which are having the same precedence? So among the arithmetic operators which are having dreaming, Sudarshan. So multiplication, division and modulus. Likita, you have given subtraction and all. 3 operators which are having higher precedence and equal precedence than the others, which are in arithmetic operators are multiplication, division and modulus. These 3 are having equal precedence and they are having higher precedence than the addition and subtraction. So what we have to do if they are having the same precedence? So in the first definition, we saw that the sequence in which operators in an expressions are evaluated is known as a precedence of operators. Now, in the next definition, we are learning if 2 or 3 operators are having the same precedence, then we have to follow the associativity of the operators. So you can either follow. So for these operators, there are left to right and right to left associativity. So we will see if 2 operators are having the same precedence, we have to follow associativity rule, that is from left to right. We have to, in this example, we are going to see how arithmetic operators will be evaluated in an arithmetic expression. And in case if you are having 2 or 3 operators having the same precedence, how it will be evaluated. So arithmetic expression, in this example, we are considering an arithmetic expression without parenthesis, without bracket, without parenthesis. An arithmetic expression with parenthesis and without parenthesis will be following different order of evaluation. An arithmetic expression without parenthesis will be evaluated from left to right using the rules of precedence. So in other go, if you have an arithmetic expression, it will be evaluated from left to right and it will be following the rules of precedence of operators. There are 2 distinct priorities in arithmetic among the arithmetic operators. Multiplication, division and modulus, these 3 operators are having higher precedence than addition and subtraction. So we have to follow two distinct priorities, or we are categorizing it under two distinct priorities, high priority and low priority. And after that, we will be considering, or when we are evaluating the expression, we will be following the left to right precedence. So in case if you are having an expression with these three operators, that is multiplication, division and modular division, which are having the same high priority, you will have to follow left to right associativity to solve the or evaluate the expression. Evaluation process include left to right passes through the expression. So we will see how these passes are happening for solving and or evaluating an expression. During the first pass, high priority operators are applied, and during the second pass, so as we in arithmetic expression we have only two priorities, high priority and low priority. There are two passes. In first pass we will be considering high priority, and in second pass we will be considering the low priority operators. And again, in each pass, we will be having 2-3 steps in order to solve the expression, because depending upon the number of operators being used in the expression with the same priority. So here is an example of an arithmetic expression which are having operators. So it is an expression having more than one arithmetic operator: subtraction, division, addition, multiplication, and again subtraction. So here A is a variable which is having a value 9, B 12, and C equal to 13. The statement or the arithmetic expression x equal to A minus B by 3 plus C into 2 minus 1 will be rewritten using or substituting the values of the variable. So instead of A, we will be writing as 9. So rewrite the same arithmetic expression using or substituting using the values 9 instead of A, and then you know how to rewrite the equation 9 minus 12 by 3 plus 3 into 2 minus 1. So as we follow in max, here also the same rules have been applied in order to solve the arithmetic expression in a C compiler. So as we had told in the previous slide, there will be, so in order to solve an arithmetic expression, there are two passes. In first pass, we will be solving the or evaluating the operators which are having high priority, and in the second pass, we will be evaluating the operands or the expression which are there in the low priority. So in the first pass itself, what are the operators which will be solved? All those operators which are there in the high priority. Which are those high priority operators? Multiplication, division, and modular division. So if you have in the arithmetic expression any of these three operators, it will be solved in the first pass. So depending upon the the number of, if you have only two operators from the high priority, you will be having only 2 steps. If you have 3 operators from the high priority, you will be having 3 steps. Steps will be depending upon the number of operators of high priority. Okay, so in the first pass, what we will be doing is we will be following the left to right associativity. So in the first pass, from when we are following from left to right, we will first encounter a subtraction. Simple. So you know it is not belonging to high priority operator. So we will further move and we will see and we will encounter a division operator. So what will be the first thing which will be done when we encounter a division? You will be taking both the operands on either sides, because it is a binary operator. It will be evaluating the expression 12 by 3, right? So 12 by 3 will be giving you 12 by 3 will be giving you 4. So rewrite the equation after solving in the first pass, after solving the equation 12 by 3 or the high priority division operator. So you will be getting 9 minus 12 by 3 will be 4, right? Substitute 12 by 3 by 4 and then write the remaining part of the expression plus 3 multiplied by 2 minus 1. Right? So we are considering it as the first pass. In first pass, we solved only one part. Now we are going to going for the second, in first pass, second step. So again, we will follow the left to right. When we move from left to right, we will first encounter the subtraction. Then you will be, so here only, no? First you will be encountering a a subtraction symbol, then you will be encountering an addition symbol, then you will be encountering a multiplication symbol. When you encounter a multiplication symbol, it will be taking the two operands on either sides because it is a binary operator, and it will be solving 3 into 2 will be 6, right? So we will rewrite the equation or the expression 9 minus 4 plus, instead of 3 into 2, we will be writing it as 6. 6 minus 1. So in the second step of the first pass, we will be rewriting the equation or the expression solving the high priority operators. As we had only 2 high priority operators, we have only 2 steps in the first pass. Understood? So now moving on to the second pass. Moving on to the second pass, in which we will be solving the low priority operators. Again, when we are moving from left to right, the first, so you can write the expression again, 9 minus 4 plus 6. Plus 6 minus 1, right? So this will be the expression which we will be getting from the first pass. So here, when we start from left to right, again we will encounter 9 subtract minus 4, right? So this will be the first symbol which we will encounter, 9 minus 4. So when we encounter a subtraction symbol, again it will be taking 2 operands on a left and right of subtraction. So you will be solving this expression to get a value 5, right? So instead of 9 minus 4, write it as 5. Now rewrite the remaining part of the equation, plus 6 minus 1. Now in step 4, again when we move on from left to right of the previous equation, we will encounter a addition symbol. So when we encounter an addition symbol, what we have to do? We have to, as addition is a binary operator, takes the two operands on either side, 5 and 6, and rewrite in the form of 5 plus 6 will be evaluating and substitute, or we'll get the value 11. So when you write the equation again or expression again, instead of 5 plus 6, write it as 11. Then the remaining expression is minus 1. Now again in the step 4, after rewriting the equation, when we evaluate from left to right, we will encounter a minus symbol. So when you encounter a minus symbol, again it will take 2 operands on left and right. 11 minus 1 will be giving you 10. So rewrite the equation in the step 5 as x equal to 10. So this will be the order of evaluation of an arithmetic expression if it is not having a parenthesis. Now we are moving on to evaluation of an expression with parenthesis. So as I had told before, we will see in the next slide that here above all the operators which we have studied, parenthesis is having the highest priority. Parenthesis will be having is listed along with the other operators, but I am telling it will be having the highest priority. So we will be constructing a table, I told, no? So we have already seen that arithmetic operators, unary operators, and this one, bitwise left and right shift, relational operators, bitwise and bitwise or logical operators, logical or. So this will be the table of all the operators together. And then among we had studied only from arithmetic operators. Among the arithmetic operators itself, we have studied about the unary plus and minus, and yesterday we had seen increment and decrement operators. So finally you can see that all the unary operators, listen here, all the unary operators will be having higher priority when compared to all the remaining other operators. So among the different categories of operators, we had studied that in arithmetic operator we have a unary operator, and increment and decrement operator is also a unary operator, and we have the logical not operator, which is again a unary operator. And the type, size of, all these are type we didn't study, that I'll take in the next topic. Size of is also a unary operator. Whatever be the unary operator, what we have studied till now, again pointers and address, no address, you know, in scanf we are using address operator. All these are the unary operators. Why we are telling it as a unary operator? It takes only one operand. Priority or the precedence of all the unary operators are higher than the binary operators. And even above the unary operators, the precedence of unary operators comes the precedence or priority of our parenthesis. Are you able to see? The parenthesis is having highest priority, and comma operator, which is studied under special operators, having the lowest priority. And I told you, in order to use comma operator, always use it along with the parenthesis. So high priority combination with the lowest priority, right? So it will be ensuring that parenthesis will ensure that comma, which is having the low priority, but still it will be taking getting the highest precedence. So as I was telling in the previous slide, parenthesis will be changing the order of precedence of any of the operators listed below in this table. Got it? So here we are going to see the same arithmetic expression or an arithmetic expression in which the order of evaluation will be changed using the parenthesis. Are you able to hear? Abhishek MP. The order of evaluation can be changed by introducing the parenthesis into an expression. So if you are writing an expression, arithmetic expression, using and without and with using a parenthesis, will be evaluating and giving you a different value for the same expression. That we will be doing it using a C program. But now for the time being, you can understand that this is an arithmetic expression which is having parenthesis. So x equal to a minus b by 3 plus c multiplied by 2 minus 1. So here if you rewrite this expression without parenthesis and with parenthesis, the order of evaluation will be different and the answer you will be getting also will be different. The expression within the parenthesis, if you are having an expression, the expression within the parenthesis will be having assumes the high priority. So whatever be the multiplication till now we were thinking is having highest precedence than addition and subtraction. Now what happened? We have put a parenthesis for the addition, an expression of addition, expression with the addition operator. Now what will happen? This will be evaluated first. So whatever we have enclosed within the parenthesis will be having higher precedence than the multiplication symbol. So when we evaluate this expression, you will be seeing that the expression which is given within the parenthesis, even if it is having low priority, even if the arithmetic operator, the addition is having low priority, it will be getting more precedence than the multiplication. This division is also there and multiplication is also there, but the order of evaluation or the precedence will be changed completely by the use of parenthesis. The expression within the parenthesis assumes high priority. So here the expression contained in the leftmost parenthesis set is evaluated first and then the rightmost is evaluated last. And if you are, you can see that here the difference between 3 plus c and 2 minus 1, both are having operator that addition and subtraction. Addition and subtraction, in arithmetic, among the arithmetic expressions, addition and subtractions are having low priority and they have among them they have the same precedence. But now in this expression we have both expression 3 plus c and 2 minus 1, which are having the addition and subtraction are having low precedence, but both these small expressions are delimited with the parenthesis, right? So the both are having just now I told if they are putting an expression within parenthesis, that will be evaluated first. So now among these two there is a tie. Both are having low precedence when compared to this division and multiplication, but these two are having equal precedence. And now both these expressions are delimited with the parenthesis. Now which expression will be evaluated first? So in this case, when two operators are having the same precedence, or whenever two expressions are having the same precedence, we have to follow the associativity rule, right? So first we will be first we considered the parenthesis, then we saw that there are in the expression where we have two expressions within which are delimited by parenthesis. Then we have to see which is having like we saw that both are having the equal precedence, right? Addition and subtraction are having the equal precedence. So now we have to consider the associativity, right? So from when you consider the left to right associativity, which parenthesis is coming first or which expression is coming first will be evaluated first. So you know, see from the expression 3 plus c is the expression which is coming first. So in this expression, we will be evaluating 3 plus c. Okay, so the expression containing the leftmost parenthesis set will be evaluated first because we follow left to right associativity. So this will be evaluated first and then the rightmost. So after evaluating this expression, we will move on to the, again when we move from left to right, we will encounter the next parenthesis and then it will be evaluated. Evaluation of an expression with nested parenthesis. Suppose we have an expression with a nested parenthesis. Evaluation of an expression with a nested parenthesis will proceed outward from the innermost set of parentheses to the outermost. So suppose if you have rewrite this expression with an outer parenthesis, within this outer we have two inner. So what will be the order of evaluation? First, we will be evaluating the innermost. Innermost itself, if you have to, that means it will be evaluating following the left to right associativity, right? So first we will solve this left and then the right, and then finally we will be evaluating the whole parenthesis within the outer. So after substituting the value of 3 plus c and 2 minus 1, we will be evaluating we stopped with the order of evaluation, how it will be changed using the parenthesis. So if you have parenthesis in an expression, the order of evaluation will be changing, or the precedence order, what we were studying till now. So that order will be changed if you are using parenthesis in an expression. The expression within the parenthesis assumes high priority. And again, if you have more than one expression enclosed in parenthesis, the parenthesis which is leftmost, the leftmost parenthesis expression will be evaluated first. And then if you have nested parenthesis, so if you have expression with a nested parenthesis, the innermost set of parentheses, expressions which are there in the innermost set of parentheses will be evaluated first. So as I had told you from the beginning itself, so the arithmetic operators, we studied starting from the arithmetic operators. And among the arithmetic operators itself, we were knowing that the unary operators are having higher precedence than the binary operators, multiplication, division, modulus, and addition, subtraction. So those unary operators are all put together, and it is placed above any of the other operators. So here the unary plus and minus is above the arithmetic or the remaining arithmetic operators, and the topmost precedence will be for the parentheses. So the brackets, and then these special operators what we have studied, the member function and also the square bracket, are all coming above, are having more or the topmost precedence, followed by the unary operators. So you should remember that unary operators are having the second precedence after the parenthesis. Mostly we will be using only parenthesis from here, and then the structure, this one, member functions. But for the time being, you can remember that the parenthesis followed by the unary operators, followed by the multiplication, division, and the modulus or the modular division arithmetic operators, then the addition and remaining addition and subtraction, followed by the left shift and right shift. When we were taking that bitwise left and right, we were not talking about the precedence, but you can see that the left and the right shift is having higher precedence above the relational, while the bitwise and bitwise or an exclusive or, all these are having precedence lower than that of the relational operators. And the relational operator among them itself, we know that the comparison, or they are used for the comparison. So the less than or equal to, greater than or equal to, all these four are having more precedence and the equality operators. We know double equal to and not equal to, and all these remaining operators are categorized under relation operator. But these equal to operators are having lesser precedence than the relational. Then the logical and operator. So when we are giving only one ampersand, it is bitwise and. When we are giving two ampersand, you know, it is logical and. Logical and logical or. These two are having lower precedence than the bitwise operators. And one more thing is logical not, which is again a unary operator. You see the top, no, the unary operator logical not is having higher precedence. And the ternary operator. So the order you can just remember, no need of by hurting everything. Unary operator is having higher precedence than the binary. So all the binary operators are listed over here. Then comes the ternary. Okay, so by unary followed by the binary, then the ternary operators. Then comes the assignment operator. Least precedence is for the comma operator. So in order to, when we studied the special operators, we studied that the comma operator, which is having the least precedence, in order to increase its precedence, we put the expression within the parenthesis. So just for understanding, I just kept what in your, when we were studying the arithmetic operators, we were learning about the precedence, right? That is enough. So when they ask, you can tell about the order of precedence, high priority, low priority. Among the arithmetic operators, the unary operator plus and minus is having higher precedence. And the binary operators, remaining binary operators, among that itself we have high priority. High priority operators are multiplication, division and modular division, and low priority operators are addition and subtraction. And then we were telling about the relational operators. Relational operators are having lower precedence than that of the arithmetic operators. Then we were learning about the logical and logical not and logical or. So all these three, among these three itself, you know that logical and logical or is having lower precedence than the relational operators. But the logical not, which is a unary operator, again is categorized well above all the other binary. So all the unary operators you can list off, and then when question is asked for unary operator, you can write all these unary operators. Increment operator, decrement operator, unary plus and minus, logical not, complement. All these are taking only one operand, right? Type we will study in the next slide. Then pointer will be studying in the pointers chapter. Address we have already seen in scanf. We will be using or preceding the variable name with an ampersand symbol in order to indicate the address of the location. Size of we had studied in the special characters. So size of is also a unary operator. And then, so when we write about the logical operator, the three logical operator, logical and logical or and logical not is also along with the other unary operator. When we studied logical operators, we just studied that logical not is having higher precedence above the relation operators, but actually it is categorized along with the. So no, for better understanding, all the unary operators, whether it belongs to the arithmetic operators or it belongs to the logical operator or it belongs to the special operator, all the unary operators are having higher precedence than the arithmetic operators. So you can see here that will be easy for you to understand. You know that this increment operator is and decrement operator, or these two are unary operators. And then this addition and subtraction or unary plus and minus, which is belonging to the arithmetic operators, is also having high precedence. Logical not, which is coming under logical operators, is having higher precedence. And the size of pointer and the address of all these are the special operators, which is also coming as a unary operator. It's coming under and it's having higher precedence. Complement, which is coming from which the bitwise operators, that is also having higher precedence. Okay, so I hope this will be a summary of all the operators. So even though we studied among the arithmetic operators, we studied that unary plus and minus is having higher precedence. This is easier to understand and remember. You can write all the unary operators together and it is having higher precedence. And only ternary operator, which is our condition operator, is having lower precedence than all the remaining binary operators. Now, so following that, so we have studied or we have seen that an expression within the parenthesis and an expression without any parenthesis. So expression without parenthesis, how the evaluation will be happening depending upon the, so if it is an arithmetic expression, so it will be arithmetic expression will be again considered in terms of the high priority and low priority. And if you have more than one arithmetic operator which is belonging to high priority, in the first pass itself we will be having 2 steps or depending upon the number of operators used, and in the second pass we will be seeing the low priority, that is addition and subtraction. And if you have more than one operator from the low priority, then depending upon that, that many number of steps will be there. Now in this example, we have an expression which is having parentheses. So as I told in the previous slide, if you have an expression with the parentheses, all the precedence of high priority and low priority will be changed. And then we will be giving more precedence for the expressions which are given in parentheses. So here, when we just start from using the left association, we encounter a subtraction symbol and followed by a division symbol. So we may think that it may stop at the division symbol and take 2 operands and do the evaluation, but it is not like that. When we have a parenthesis, it will first solve the expression which is given in the parenthesis, and you can see that there are 2 expressions which are enclosed in parenthesis. So in that case, it will be solving the first expression which is encountered, the first expression which is enclosed in a parenthesis. So here we can see that 3 plus c is the expression which is encountered first when we go from left to right. So you will be solving 3 plus c. So first we will rewrite the equation or the expression using or substituting the values of a, b and c. So a is 9, b equal to 12 and c equal to 3. So you will rewrite the equation as 9 minus 12 by 3 plus 3 into 2 minus 1. So in the first pass, so we will be seeing that 9 minus and then you will be encountering a division symbol and again the parenthesis. So the first parenthesis within the expression within the parenthesis is 3 plus 3. So you will be adding 3 with 3 and you will be rewriting the equation with the 6. So in the first pass, as a first step, we will rewrite the equation solving the expression which is encountered as the which is written in the first parenthesis. So 9 minus 12 by 6. Then you write the remaining part of the expression multiplied by 2 minus 1. In step 2, what will happen? Again, when it starts from the left to right, you may encounter a division, subtraction division, but you know that parenthesis is having more precedence, so it will move towards the parenthesis. So 2 minus 1 is 1. So you can write rewrite the equation solving 2 minus 1, 9 minus 12 by 2 multiplied by 1. So you will be rewriting the equation solving only the expression which is given in the parenthesis. Now towards the second pass. So in the second pass, what will happen is you will be having a equation which is not having any parentheses. So again, we have to follow the high priority and low priority. In high priority, what all are coming? In high priority, you have multiplication, division, and modulus. So in an expression with the parenthesis, there will be 3 passes. In first pass, we will be solving the expressions given in the parenthesis. In second pass, we will be solving the expressions which are having high priority like multiplication, division, and modulus. And then the third pass, we will be solving the low priority addition and subtraction. So in the second pass, what will happen? When we start from the left side, 9 minus 12 by 6, you encounter a division symbol. It take two operands, 12 and 6, and it will be dividing 12 by 6 to give 2. So it will be rewritten as 9 minus 2 multiplied by 1. And in the second pass, so when we again move from left to right, you know that it first encounters a minus symbol, then in subtraction, and then it moves towards to find the multiplication. You know that multiplication is having higher priority. So it will be taking two operands, 2 multiplied by 1. So it is 2. So it will rewrite the equation as 9 minus 2. In the third pass, what will happen? Third pass, it will be taking only the low priority addition and subtraction. So it will be 9 minus 2. It will be writing it as 7. So parentheses allow us to change the order of priority and also to improve the understandability of the program. So if you write an equation or an expression without parentheses, you may get a different answer, and if you are giving what you actually mean is like you have to divide 12 by 3 plus c, you have to put within the parentheses. It will be giving better understandability of the program. Okay, so the rules of evaluation of the expression, these are just topics which you can read and understand. Still giving attendance only, no? Here. So rules for evaluation of an expression. Evaluation of an expression. First, parenthesized sub-expressions from left to right are evaluated. So you taking into consideration both the expression with the parenthesis and without parenthesis, we are writing the rules for evaluation. First, we will be solving the parenthesized sub-expressions which are coming first when we evaluate from left to right. If parentheses are nested, then evaluation begins in the innermost sub-expression. I don't know. If you have more than one parenthesis, one after the other, then the leftmost expression within the parenthesis is solved first or evaluated first. If you have nested parentheses, then the innermost sub-expression is evaluated. Now, the precedence rule is applied in determining the order of application of the operators. Next comes up, so after solving the expressions within the parentheses, then we apply the rules of within the parenthesized expression also, we will be following the order of precedence. So you know that operators are having high priority and low priority. The precedence rule is applied to determine the order of application. Jeevan, you're joining now.
No, ma'am, it's automatically disconnected.
Automatically, nice excuse, no, automatically disconnected. I can see 33 participants. Before it was only 29 when I started. The associativity rule is applied when two or more operators of the same precedence level appear in the sub-expression. So when I'm having first hour, I'll take attendance in the beginning itself. You are informed to join 5 minutes before, but because of this 40-minute session, we are starting at correct time. Associativity rule is applied when two or more operators of the same precedence. I don't know, when we are having two or more operators of the same precedence appear in the expression, then we follow the left to right associativity rule. Then arithmetic expressions are evaluated from left to right using the rules of precedence. These rules I had given before also, but I am just summarizing in a single slide because in the beginning we were not considering the parenthesized sub-expression. So this will be the altogether, no, all the rules you can write together. We will be writing about parenthesized sub-expressions with and even nested parenthesized expressions. Precedence rule, if you have same operators, two or more operators having the same precedence, then arithmetic expressions will be evaluated from left to right using the rules of precedence. When parentheses are used, expressions within the parentheses assume the highest priority. As I told before, when all the precedence rule will be rewritten when we, or it will be changed when we are using parentheses. So this example you can execute and see, and you can solve now in your note. So what is that? A equal to x equal to you know that 9 minus 12 divided by plus c value is 3, right? And then multiplied by 2 minus 1. Okay. Okay. So in the next step, we need like how the so when we are trying to solve from the left side, try to solve from the left side, what will be the first operator which is precedence? First you will be encountering a minus sign. So you know that minus is having lower precedence, right? Minus is having lower precedence. What will be solved first? Then comes the division operator, right? So it will be solving 12 by 3. Gautam, are you?
Yes, ma'am.
So what will be in the next pass? What will be solved first? After subtraction comes division. So division is having
Division.
priority. Here there is no parenthesis, right? So we will be solving division. So it is like 9 minus. How? What will be solved now? 12 by 3. Right? 12 by 3 is what?
4.
4. So you
4.
have to write it as 4. And then the remaining expression, plus 3. And then multiplied by 2 minus 1. So here, now what will happen? Again, for the next pass, when it starts execution from the left side, it will encounter a subtraction symbol, then addition, and then comes the multiplication. You know that multiplication precedence. The multiplication symbol will be two operands on the left and right. So what is the two operands for the multiplication symbol? 3 and 2, right? So it will be multiplying 3 into 2 is 6. So you can read 9 minus 4 and then what is that? Plus symbol 3 into 2 is 6, right? So you will be rewriting 3 into 2 as 6 and then minus 1. In the next step, what will happen now? So 9 minus 4. So again, from the left, when we start, it will key symbols are over or operators are over. So it will now start from this side. It will encounter a minus symbol. It takes two operators. 9 minus 4 is 5. So you can rewrite the equation expression as 5 plus 6 minus 1. Now in the next step, what will happen? So here again, when we start from left, we will encounter an addition. It takes two operands. 5 plus 6 is 11. So you can rewrite it as 11. So in the next step, we will be solving 11 here. Asking the doubt here somewhere, I think. Gautam.
No, ma'am. Here itself. Here itself, ma'am.
So this will be the order. So you'll be getting x is 10. But in the same expression, when we are putting a parenthesis like this, what will happen? So when we are putting a parenthesis in the next, this one, no, you know that these expressions which in the bracket will be getting more precedence, right? So you will be you will be rewriting it in different form. That is 9 minus. So you can solve. I am just writing within one step. 9 minus 12, then 3 by 2, right? So how we will be writing it? 9 minus 12 divided by. So what will be solved first now? The expressions which are there in the parenthesis. 3 plus 3 will be what? 3 plus 3 is
6.
6. So you will be rewriting it. And then you can write the remaining, right? But I am solving. Okay, I will show you. So the next pass, what will happen? Again, when we start, you will see the parenthesis. So you have to solve the parenthesis first. You will be solving. So we are ignoring multiplication and all because we have more important or more higher priority expressions within the parenthesis. 2 minus 1 is, what is 2 minus 1? 1, right? Again, in the next step, what now parentheses are over. So when we start the evaluating the expression, first it will encounter the then when it encounter a division, right? So which will be solved first. After division comes a multiplication. So here that division and multiplication having higher priority, but as division is encountered first, we will consider 12 by 6. 12 by 6 is 3, right? And then write the remaining equation. What? Somebody? Okay. Kiran Kumar has come now. After many days, I am seeing him. Then after this, what will happen? Now, 2 multiplied by 1, right? Multiplication is having higher priority. We will be rewriting the equation by doing the 9 minus 2 into 1 is 2, right? So the next step, that is 9 minus 2, 9 minus 2 is 7. So it is not x, no, this is y. Okay, second equation. So the second equation, expression which is having parenthesis, 2 parentheses, which is, it will be solving to give the y value as 7. Now, what's the next expression? Neeraj, are you there? How does it work? After left, I think.
Yes, ma'am.
Ah,
Yes, ma'am.
yes, ma'am. Then you tell me what will be the answer for this.
Your voice is breaking, ma'am.
Voice will be breaking. When I am asking, you will tell voice is breaking.
4.
Hmm.
4 is the answer, ma'am.
Huh? Tell me the answer. Substitute and tell me the answer.
4 is the answer.
4 is the answer, but how we are getting 4? So in this,
9 in.
first. 9,
Okay, ma'am. 9 minus
9
9 minus bracket 12 divided by 6
So this innermost parenthesis will
into 2
into 2 minus
into 2 bracket minus 1. Next step, ma'am.
9 minus
9 minus
it is
2 into
12, which is encountered
2
first.
into 2
No, 12 by 6 division operator, right?
division.
Division and multiplication is there. Both are having same precedence.
Yes, ma'am.
When it comes from the left side, whichever is coming first will be solved first. So 12 by 6 is solved first. 12 by 6 is what? Divided by 6 is 12 divided by 6 is 2. Then you write the remaining part.
2.
Multiplied by 2. Then minus 1. In the next step, what will happen? 9.
2 into 2.
2 into 2 is 4. Right? 4 minus 1. So here, and then it will be 9 minus 4. Both are subtraction, but when we start from the left, 9 minus 4 is what? 5. 5 minus 1. So here, the last step, we will be getting the answer as 4. Understood? That will be 4. So now it is easy, no? I explained and the answer. Just send that for the attendance. Now the next topic is understood, no, Gautam? I'll be sending another question.
4.
You should be solving. Okay. Type conversions. Now the next topic is type conversions. What are the different data types? What are the what are the different data types that we studied? Gerard, it is correct. X equal to 10, Y equal to 7, and Z equal to 4. Not sure. That is correct only. Okay. So what are the different data types that we studied in the first chapter? Tell me. Rahul, Pradeep, Asha, integer, float, only those two, character, double, shortened, everything we studied, no? Long, double and all. So now we are going to study how to convert from one data type to another data type. Okay, good. So C permits. We have studied when we were learning about the arithmetic operators. We know that mixed mode is also possible for evaluating an expression. Some of the variables may be declared as an integer. Some variable may be declared as a float, and you can write an expression using both the two or three different types of data type. So C permits mixing of constants and variables of different types in an expression. So when we are writing an expression A plus B, A can be of data type integer and B can be of data type float. So an intermediate value has to be converted into the proper type for the evaluation of an expression. So we will be getting, suppose we are having in the previous example, you saw that we have intermediate value. What is intermediate value? The value which is got before the final answer. In this example, we had many intermediate value, right? When we solve 9 minus 2 into 2 minus 1, we get an intermediate value of 9 minus 4 minus 1. The final answer is 4. So the answer which we are getting in each step before the final result is known as an intermediate value. So any intermediate value has to be converted into a proper type for the evaluation of an expression. There are two ways in which we can convert this intermediate value. One is known as implicit type conversion. The other is known as explicit type conversion.